Hello,
Hi,
Hi,
my name is Riccardo Longo,
I'm Melissa Yexley.
I'm Claudia.
and I am a tenure track researcher at the University of Turin and INFN Turin, and I work for the Atlas Aviation program.
I'm a researcher at UCL. I search for long-lived particles and I also make event displays like this one here.
I am a researcher at INFN Trieste and Udine, and I work on the Atlas trigger system.
I have chosen this event display up here as my favorite image from the Atlas Aviation program because it encodes one of our core goals, which is to understand the microscopic structure of the quark-gluon plasma, or QGP. The QGP is a hot, strongly interacting medium that characterized the early stages of our universe and that can we recreate in the laboratory at LHC thanks to heavy ion collision like the one that you can see up here. You can see that the collision is very busy because the two ions hit head-on, generating sizable amount of quark-gluon plasma. And the jets, these two cones that you can see here and here, are our microscope for it because these are spray of particles generated at the early stages of the collision that experience the plasma before getting to our detector. And so this is our way to study the microscopic structure of this incredible state of the matter.
Every winter, we shut down the Large Hadron Collider so that we can perform repairs on it and also on the detectors that are located around the ring of the Large Hadron Collider. Then, in the spring, when we turn it all back on, we have to test that our detectors are working again. So one of the steps that we do for this is so-called a beam splash test. So we circulate one of the proton beams around the ring, smash it into a collimator, which is upstream of the detector. These protons then interact with the material in the collimator, and then they create the spray, which then creates a splash of particles within the detector that lights it up and looks like this.
The favorite image to explain my job is the one above. You can see my cat monitoring the Atlas trigger system from home. The LHC gives us collision every 25 nanoseconds, and we cannot afford saving all this data that are coming at such a high rate. For this reason, we prepare algorithms that decide in advance which kind of data would be interesting to look at after the fact. Once the algorithms are ready, they start running, and we have to monitoring and make sure that everything is following properly and we are saving the data fine. The plots that my cat is looking at right now are the same plots that are monitoring in the control room from the shifter and at home from the expert.